Welcome back to 5-Minute Chemistry. Today we are going to be talking about ions. Both anions and cations will be on the menu. When we first talked about discovering the electrons were removed from an atom and then were detected, so we already know that electrons can be removed from atoms. And what happens is that while electrons are bound to the nucleus via the electrostatic force, which is a very strong force, so the positively charged nucleus and the negatively charged electrons have the attractive force between them, but as we learned from the potential energy, so the closer these two charged things are together, the lower the potential energy is. So if you give these particles energy from the outside, their potential energy can be increased. That means they get further away from each other. So to remove an electron, it needs to receive energy from somewhere to overcome this potential energy that binds it to the nucleus of the atom. When an electron is removed from an atom, which is a neutral particle, a cation is formed, so we call positively charged ions cations. And example for this would be like calcium. If you remove an electron from calcium, then you get a calcium positively charged cation, so calcium plus ion and an electron. And you can further remove electrons from cations. So as long as a cation has electrons, you can keep removing electrons from it. So from calcium plus ion, you can get a calcium 2 plus ion plus an electron. And while in vacuum, for example, in a very low pressure situation, you could remove all the electrons from an atom. It is something that requires a lot of energy, and as the electrostatic force is very strong, as soon as you have positively and negatively charged things close to each other, they will want to lose this potential energy and get close together again. So in nature, you don't really get ions that are higher than 3 plus charge. Here the unit of the charge is the electron charge. So calcium 2 plus ion is an ion which lost 2 electrons. The magnitude of the charge is equivalent to the 2 electrons charges, but it's plus and not minus. So the opposite thing can also happen. So a neutral atom, even though it's neutral, it can still capture electrons. So not all atoms are like that. Some of the atoms can bind these additional electrons that they find out in the wild, because even though an atom is a neutral particle, once the electron gets close enough to an atom, it might feel the differential electrostatic force between the electrons of the atom and the nucleus of the atom. So it might be able to lose some potential energy by moving closer and getting into this atom and form an anion. So anion is when a negatively charged ion is formed. We call that an anion. And an example for that would be oxygen. So you can add an electron to oxygen and get O minus, and get another electron into O minus, and you will get O2 minus. And this is how we write the symbols of ions. So here we have an aluminium cation and a sulfide anion. We always use the same symbol as for the element. So from an aluminium atom, you always get the aluminium ions, and from the sulfur atom, you will always get the sulfide ions. So nomenclature for anions with the negatively charged ions is a little more complicated than for positively charged. But in any case, so if you write the element, then you will have to write the charge of the ion to the top right corner on the index over there. So first you write the magnitude of the charge, so 3 plus or 2 minus. Then you write if it's positive or negatively charged, and the unit of the charge is going to be the electron charge. So if it loses electrons, it will positively charge. If it gains electrons, it will be negatively charged. So you cannot have fractional charges in these kind of ions. If you have a single ion and you know what nuclide it has, this is how you might write it. So you can write in the bottom left-hand side index the atomic number, which is going to be the number of protons. A lot of times it is not written because from the symbol you should be able to unambiguously find out what the atomic number is, but we can write the mass number of the nuclide if we have a single ion, and this mass number is going to be the neutrons plus protons, and the mass number and the atomic number together, they define the nuclide. And then for the ion we can write the charge to the top right index over there, which is going to be the number of protons minus the number of electrons. So if we have more protons than electrons, then it will be a positive charge, and if we have more electrons than protons, it will be a negative charge. So that's why from the protons you subtract the electrons. So in this ion, for example, we can know that there are 26 protons because the atomic number is 26. From the mass number, we can calculate the number of neutrons. So we have to subtract the atomic number from the mass number, which will be 32. So 32 neutrons here. And then for the charge, so we can see this is a 2 plus charge. That means we have 2 more protons than electrons, which will result in 24 electrons for this ion. Okay, so this is it for today, and I will see you tomorrow.